So in homework packet 4.2, we're going to be taking what we learned in 4.1 and applying it to finally graphing the functions that we've been taking a look at. In this first video for lesson 4.2a, we're going to look at graphing linear equations. Now, graphing linear equations is something you've done for several years now in Algebra 1, geometry, and even in some of the middle school math classes that you've taken. So let's review really quickly how to graph a linear equation, specifically the type that you're used to. But then we also want to understand that one of the other things that we always want to make sure that we plot and label with a linear equation. It's good practice, and it allows us to find out some of that other important information. Is we want to be able to plot and label the x and y intercepts if they exist. So we'll see what that means. So let's go ahead and graph this equation right here. Now we remember that if we are in the form y equals mx plus b, which we are, that's slope-intercept form of a linear equation, that this last value right here, b, is our y-intercept. So we know that our y-intercept is at -7. So I'm going to go down to 4, 5, 6, 7, -7 here, and I'm going to put a point. And then we know that the value of m is our slope. And so from this -7, our y-intercept, we use our slope, and in this case it's a 4/3. We know the top number tells us rise, so it's +4, so I go up 1, 2, 3, 4. The bottom is a +3, so I go to the right 1, 2, 3. So here's my next point. And I can continue that pattern to get additional points. I can go up 1, 2, 3, 4, over 1, 2, and 3. So I'm going to draw the line through those points now. And that line on this coordinate plane is a graphical representation of the relationship between x and y in this function right here. Okay. So we have the graph. That's the first thing it asked us to do here, graph the following linear equation. But it also wanted us to plot and label the x and y intercepts. Well, let's look at the simplest one first, the y-intercept. The y-intercept is the point at which my graph crosses the y-axis, and that's that point right there. Well, we know that the y-intercept is at the point -7, but what is that as a coordinate point? The x-coordinate of any y-intercept is 0 because it's on the y-axis, and then the y-intercept here, or the y-coordinate, is -7. So I knew, just based on the setup of the equation, that my y-intercept was down here at 0, -7. But now I've got my x-intercept right here. It's the point at which my graph, the line that I drew, crosses the x-axis. Now I want to be able to find that coordinate point. Okay? Now I don't want to guess. I don't want to just estimate. I want to know exactly where that point is. Okay? Now, I don't have as nice of an easy of a trick as just looking at a specific number in the equation as I did for the y-intercept, but I do have from homework packet 4.1 a method to be able to find x-intercept. How do you find your x-intercept? You plug 0 in for y. So 0 equals 4/3 x minus 7. I'm going to solve this for x, and it'll tell me where my x-intercept is. So I'm going to add 7 to both sides. 7 is equal to 4/3 times x. So it's divided by 3, so I'm going to multiply by 3 to get the 3's to cancel out. Whatever I do to one side, do to the other. So 7 times 3 is 21, is equal to 4x. Let's divide by 4. And I end up with x is equal to 21/4, which is 5.25. Does that match where we are over on the graph here? If I start at the origin, I count over 1, 2, 3, 4, 5, and a little bit more. That looks dead on. So let's go ahead and label this. We know the x-coordinate is 5.25 of our x-intercept. And what is the y-coordinate of an x-intercept always going to be? Because it's on the x-axis, we know the y-intercept is always going to be 0, or the y-coordinate, I should say, is always going to be 0 for the x-intercept. So there's my graph plotted on a coordinate plane with the x and y intercepts also plotted and labeled. So I'd like to look at one additional linear equation, and it's in a different form than you may be used to in past math classes. This is the form that we call standard form of a linear equation. I know it's linear because there's no square roots, there's no logs, there's no exponentials, and x isn't being squared or to the third or to the fourth. There's just an x and there's a y, each with a coefficient in front of them. Okay? It's a linear equation because of those reasons. Now, I'm not in the nice form where I had y equals mx plus b, where I could just find my y-intercept and then use my slope. I'm not in that form at all. Now, I could go and put it in that form, but interestingly enough, there's actually a better way to graph a linear equation of this form, and what that is to simply start by calculating the x and y intercepts. So let's do that. How do you find your x-intercept? Plug 0 in for y. So that's 5x plus 15 times 0 is equal to 30. You're going to see that that just goes away because 15 times 0 is 0. So I'm simply left with 5x equals 30, which means all I have to do is divide by 5, and I know my x-intercept is at x equals 6. So on my x-axis, I can go over to 1, 2, 3, 4, 5, 6 and put a point. I know that that is the location at which my graph crosses the x-axis because that is the x-intercept. Well, what about the y-intercept? To find the y-intercept, we plug 0 in for x. So that's 5 times 0 plus 15y is equal to 30. So we can see that this time that term goes away because 5 times 0 is 0. And I'm left with 15y is equal to 30. So dividing by 15 produces y equals 2. 30 divided by 15 is 2. So now I know on my y-axis, my graph crosses through the point on the y-axis of 2. Now what's nice is I've already found the x and y intercepts that I'm supposed to plot, but also all I need is 2 points on a coordinate plane to find the graph of a line. And so what I have right here is the ability to just draw a line through my x and y intercepts, and there's the line that is the graphical representation of this equation, and I already know where both my x and y intercepts are. Labeling them, my x-intercept is at 6, 0, and my y-intercept is at 0, 2. So there it is, my linear equation graphed with both the x and the y-intercepts labeled.